On the 24th of January 1986, a spacecraft flew past Uranus at about 45,000 miles an hour. It had roughly 5.5 hours near the planet. That was the entire window. Everything humanity would know about Uranus for the next 40 years had to be collected in that time, by one machine, on one pass, with no possibility of going back. And it worked. The instruments performed. The data came home clean. What that data said was that Uranus is broken. A magnetic field tilted almost 60 degrees off its rotation axis. Nothing else in the solar system does that. Radiation belts packed with unusually energetic electrons. And, strangest of all, a magnetosphere that was essentially empty. No plasma. Almost none of the charged particles that should have been streaming off its 5 large moons, which led to a conclusion that stuck for 4 decades. Those moons are dead. Frozen, inert, geologically finished. Textbooks were rewritten. Uranus became the odd one, the planet that doesn't follow the rules. Except it does follow the rules. Voyager 2 just showed up on the wrong day. Let's get into it. To understand how a single bad afternoon could mislead us for 40 years, you need to understand how thin the data actually is. Uranus has been visited exactly once. Not once this century, once ever. No orbiter, no return trip, no follow-up. Everything we believe about that planet's magnetic environment comes from a single spacecraft passing through it in an afternoon. Voyager 2 wasn't even supposed to go there. The original mission was Jupiter and Saturn. The extension to Uranus and Neptune only happened because a rare planetary alignment made it possible, and the spacecraft was still healthy enough to try. By the time it arrived, it had been flying for 8.5 years. It was working with a computer far less capable than a modern phone, communicating across nearly 2 billion miles, with a signal so faint by the time it reached Earth that receiving it at all is a genuine engineering achievement. And it delivered. During that flyby, it discovered 10 new moons, found 2 previously unknown rings, and mapped the magnetic field of a world nobody had ever seen up close. But here's the thing about a flyby. It's a snapshot. Imagine trying to describe a stranger's entire personality from one photograph, taken on the worst day of their life. You'd get the details right, the photograph wouldn't be a lie, and your conclusion would still be completely wrong, because you happened to catch them in a state they're almost never in. That is, more or less, what happened at Uranus. Quick note before the reveal, because it matters on this channel. What follows is a reinterpretation of 40-year-old data published by researchers who went back to the original Voyager 2 measurements and compared them against solar wind conditions at the time. It's a strong, well-argued case. It is not a new observation of Uranus, because there hasn't been one. I'll be clear at the end about exactly what that means and what it doesn't. If that's what you want from a space channel, real discoveries, decoded, with the uncertainty left in, subscribe and hit the bell, twice a week. Because the thing that fooled us wasn't a broken instrument, it was the weather. Start with what a magnetosphere actually is. Every planet with a magnetic field carries an invisible bubble around itself. That bubble deflects the solar wind, the constant stream of charged particles blowing outward from the sun. And a magnetosphere isn't a fixed thing, it breathes. When the solar wind is gentle, the bubble inflates. When the solar wind gets strong, it compresses, squashed inward, like a balloon under a hand. Under heavy compression, the whole environment inside changes. Plasma gets driven out, particle populations get accelerated, radiation belts get temporarily supercharged. Everything you would measure inside that bubble reads differently than it would a week earlier or a week later. Now put Voyager 2 into that picture. When researchers went back and reconstructed the solar wind conditions around the time of the flyby, they found something nobody had thought to check in 1986. Just days before Voyager 2 arrived, the solar wind hitting Uranus intensified dramatically. The planet's magnetosphere was squeezed into an unusually compressed state, a state it happens to be in only about 4% of the time. 4%. Voyager 2 had one shot at Uranus, and it flew through the system during one of the roughly 1 in 25 intervals when the planet looks nothing like its normal self. If it had arrived a week earlier, or a week later, it would almost certainly have measured a completely different magnetosphere, full of plasma, ordinary radiation belts, a planet that looks far less strange. Think about a census taken during a storm when half the population is sheltering somewhere else. The count is accurate, the conclusion drawn from it is not. That's the mistake. Not bad data, bad timing, and 40 years of building a picture on top of it. Now the part that actually matters, because this wasn't just an error about magnetic fields. Remember the missing plasma. That absence was the main reason Uranus's 5 large moons, Miranda, Ariel, Umbriel, Titania, Oberon, got written off. The logic was reasonable. If those moons were geologically active, if they had subsurface oceans venting material into space, that material should show up as plasma inside the magnetosphere. Voyager found almost none, so the moons were probably inert. But if the magnetosphere had just been flushed out by a solar wind event, then the absence of plasma tells you nothing about the moons at all. You looked for evidence right after something swept the evidence away. And several of those moons look like objects that deserve a much closer read. Ariel has an unusually young surface with far fewer craters than expected, and long grooves that suggest material has been resurfacing it. Titania and Oberon are large enough that models of their interiors allow for oceans surviving under their ice. And Miranda is one of the most bizarre bodies in the solar system, a jumble of mismatched terrain that looks assembled rather than formed, carrying a cliff face roughly 12 miles high, the tallest known anywhere. None of that proves anything by itself, but a system that was declared dead on the basis of a measurement taken during a storm deserves to have the question reopened, and that reopening has consequences. If any of those moons hold liquid water under their ice, then Uranus isn't a boring ice giant with a broken magnet. It's a system of ocean worlds, and we shelved it for 40 years. The scientific community has, in fact, recommended a dedicated mission. An orbiter and atmospheric probe for Uranus was ranked as the top priority for a new large planetary mission in the most recent decadal survey. It hasn't been built, it hasn't been funded to launch, and the journey alone would take around a decade and a half. Zoom out, because there's a larger lesson here that applies well beyond one planet. Almost everything we know about the outer solar system rests on a small number of brief encounters. Voyager 2 at Uranus, Voyager 2 at Neptune, New Horizons at Pluto, single passes hours long by spacecraft that could not stop. We treat the results as facts because they're the only facts available, but a flyby is a single frame from a film that runs for billions of years, and a single frame cannot tell you whether what you're seeing is typical or a fluke. The Uranus case is valuable precisely because we caught it. Somebody thought to ask what the weather was doing that week. How many other conclusions in planetary science are sitting on a single frame that happened to catch an unusual moment, and nobody has thought to check? Before we finish, let's do what we always do here. Let's stand there. You're on Miranda, the innermost of the 5 large moons, and the strangest object of the group. The ground under you doesn't make sense. Miranda looks like a world that was broken apart and reassembled badly. Patches of terrain that don't belong together, sitting side by side with sharp boundaries between them, as though someone stitched together pieces of 5 different moons. Walk to the edge of Verona Rupes and look down. The cliff falls away for roughly 12 miles. That's the tallest drop known anywhere in the solar system, far deeper than the deepest canyon on Earth. Deep enough that from the top, the bottom simply fades into shadow. Gravity here is so weak that if you stepped off, you would fall for around 10 minutes before you landed. 10 minutes of falling, you would have time to think about it. Now look up. Uranus fills a huge portion of the sky, a pale, featureless blue-green sphere lying on its side, its rings running vertically rather than horizontally because the whole system is tipped over. There's no weather to watch, no storms in the visible bands, just a smooth, quiet, enormous presence overhead. And here's the thought worth sitting with. Everything humanity knows about this place, everything in every textbook, comes from one machine that passed through here in a single afternoon in 1986, before most people watching this were born. Nobody has come back. Nobody has looked again. This entire system, 5 major moons, 13 rings, an entire ice giant, is known to us from one afternoon. And that afternoon, we now think, was atypical. The fine print, because we always do the fine print. The reanalysis is a reinterpretation of existing data. It's built on reconstructing solar wind conditions in 1986 and showing they were unusual, and that a compressed magnetosphere would produce the readings Voyager saw. That's a strong argument. It is not a new measurement of Uranus, because nobody has made one. The moons being potentially active is a possibility that the reinterpretation reopens. It is not a finding. Nobody has detected an ocean inside Titania or Ariel. What changed is that the strongest reason for ruling it out turns out to be unreliable. And the honest bottom line, we cannot settle this from here. Uranus is roughly 2 billion miles away, and the only way to know what its magnetosphere normally looks like is to put something in orbit around it and watch for years. Here's my question for you. One afternoon in 1986 is still the entire basis of our knowledge of an entire planetary system. So, how much of what you were taught about the outer solar system do you think is built on a single snapshot like that? And does it change how you read the next confident headline about a world nobody has visited twice? Tell me below. I read everyone. If you learned something, the like button genuinely helps this channel get found. Subscribe for new discoveries every Tuesday and Friday. Thanks for watching Voidline. I'll see you in the next one.